Welcome everyone to our set series. Today we'll be starting with laws of set. These are just basic guide for us to work with set problem. The first law is idempotent law. A union A is equals to A and A intersection A is equals to A. What this law simply says is that a subset or any given set A joined with itself is the same thing as A. And any given set A intersecting with itself is the same thing as A. Next is associative law. Says A union into bracket open B union C bracket close is equals to A union B bracket open and close union C. A intersection bracket open B intersection C bracket close is equals to A intersection B bracket open and close intersection C. What you can take home from the associative law is that in the case of we have three sets ABC, when you have a union among them, you can move your bracket freely, either between the first two sets or the last two sets. The same thing applies for the intersection. Next, we have commutative law. A union B is equals to B union A. Also, A intersection B is equals to B intersection A. Commutativity here is just telling you that you can change the position of each of the set A union B. Then you can take B first, B union A. Similarly for intersection. Next is the distributive law. A intersection into bracket open B union C is equals to A intersection B union to bracket open A intersection C bracket close. What the distributive law is saying is that you can distribute intersection into union as it is done there. The same case for A union bracket open B intersection C bracket close is equals to A union B bracket open and close then intersection A union C bracket open and close. What that distributive law said about union is that union can also, if you have three set ABC, union can distribute over intersection as it is shown there. Next, we have De Morgan's law, which states that A union B bracket open and close prime. De Morgan's law states that A union B prime is equals to A prime intersection B prime. What it's simply saying is that if you have A union B and it is prime, then it's the same thing as switching the operation from union to intersection, and each of the set will now be prime. Similarly, A intersection B bracket open and close prime is equals to A prime union B prime. Next, we have a complement law, which states that A prime bracket open and close prime is equals to A, and the universal set prime is equals to empty set. Similarly, A union A prime is equals to a universal set. A intersection A prime is equals to empty set. Also, empty set prime is equals to universal set. Next is identity laws. A union empty set is equals to A, and A intersection universal set is equals to A. Also, A union universal set is equals to universal set. Intersection empty set is equals to empty set. Next, number set. This type of set deals with properties of numbers such as prime, odd, even, multiples, odd prime, and divisibility. Okay. For the purpose of emphasis, I will briefly define and give examples of the above named properties. Prime numbers. A number is said to be prime if it has only two factors, 1 and itself. Example, list the elements of the set A, which is equals to the set Z, such that Z is a prime number from 1 to 10, and that A is equals to, when we're talking about prime number between 1 and 10, we have 2, 3, 5, 7. Note, 1 is not a prime number because it has only one factor. Next, we define even numbers. These are numbers divisible by 2 without remainder. Example, given that W is equals to X such that X is even number from 5 to 15. List the element of W. W is equals to even numbers between 5 and 15 is 6, 8, 10, 12, and 14. Next, odd numbers. Odd numbers are numbers not divisible by 2. Example, list the elements of the set R equals to K such that K is an odd number between 2 and 11. Solution. The word between here means 2 and 11 are not inclusive. Thus, R is equals to 3, 5, 7, 9. Note, 1 is an odd number. Next, multiples. The multiple of any number is the set which contains the product of the given number, and 1, 2, 3, on and on, except when limits are given. Alternatively, the multiples of any given number, say 4, are those numbers that can be divided by 4 without remainder. Example, list the element of the set J equals to such that 1 is less than or equals to T, less than or equals to 10, and T is the multiple of 3. Solution. The range 1 less than or equals to T less than or equals to 10 is equals to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The multiples of 3 here are 3, 6, 9. Therefore, J is equals to 3, 6, 9. The next terminology is odd prime numbers. These are numbers that have the odd numbers property and are further subjected to the prime number property. Example, if U is equals to X such that 1 is less than or equals to S less than or equals to 10, and Y is equals to X such that X is odd prime, then list the elements of Y. Solution. Y odd is equals to 1, 3, 5, 7, 9. That's odd number between our range that is giving 1 less than or equals to S less than or equals to 10. Then out of this, Y odd prime of this set that is given now is 3, 5, and 7. Next terminology to be discussed here is divisibility. This is the other term for multiple. Also, we should take note that not divisible and not a multiple are the same terms mathematically. Next, we're taking some problems on number set. If the universal set is given us 1, 2, 3, 4, 5, and the set P is equals to 2, 3, 5, set Q is equals to 1, 2, 3. Find the complement of P intersection Q. The options are given. Solution. P intersection Q is equals to 2 and 3. That is the element common to P, the set P and Q. Next, P intersection Q prime, which is the element not in P intersection Q, but they are the universal set. And that will be 1, 4, and 5. Another example. If the universal set is equal to positive numbers less than 20, the subset is equals to multiples of 4. The subset Q is equals to multiples of 6. We are asked to find P intersection Q. The options are given. Solution. What the examiner wants to know from us here is that whether we can list any given set based on the definition of its terms. Like the universal set, we'll say positive numbers less than 20, and that is 1, 2, 3, 4, 5, 6, on and on, up to 19. Then the subset P, which is multiples of 4, is 4, 8, 12, 16. Multiples of 4 under the universal set, 1 and 19. Then Q, talking about multiples of 6 under this universal set, and that is 6, 12, and 18. Conveniently, we can now say P intersection Q is equals to 12, because the set, subset P and Q listed here, the only common element between them is 12. Another example. Let the universal set U be the set of integers. U being equals to X such that 0 is less than S and less than or equals to 10. What is the complement of the set B equals to X such that X is element of U, the universal set, and X is not divisible by 3? The options are given. Solution. Listing their elements based on the conditions given. As for the universal set, we start from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 0 is not listed here because of the strict inequality there. And 10 is listed among the elements of the universal set because of the weak inequality there. As for B, we have been told that B must be an element of the universal set and it is not divisible by 3. That is, out of the element listed in the universal set there, any other element that is not divisible by 3 is the subset B. And that is 1, 2, 4, 5, 7, 8, 10. We are to find the complement of B, the set B. B complement is the same thing as the set that are not in B but are in the universal set, and that is 3, 6, 9. Another example, let the universal set be equals to 3, 6, 9, on and on up to 45. And the subset A is equals to Y such that Y is less than 22. And the subset B is equals to Y such that Y is a factor of 45, where Y is an element of the universal set. Find 1, n of the universal set, 2, A union B, 3, A intersection B. Solution. To look for n of you, first we list the element in the universal set, which is 3, 6, 9, 12, 15, 18. We have gotten the pattern that is multiples of 3, 21, 24, 27, 30, 33, 36, 39, 42, 45. Thus, n, which is the number of elements of the universal set, is equals to 15. Our next question, which is 2, it said A union B is equals to, first, we list elements of A and B. In this case, A is equals to, based on the definition given, say Y less than 22. So we are listing all the elements of the universal set that are less than 22. And that is 3, 6, 9, 12, 15, 18, 21. To be able to list the element of B, applying the simple definition of factors, bearing in mind the condition given by our universal set, it will be 3, 5, 9, 15, 45. Because our A union B will be equals to 3, 5, 6, 9, 12, 15, 18, 21, 45. Also, A intersection B will be equals to 3, 9, 15. We've come to the end of the teaching today. Next, we have some exercises which we advise you try your hands on them. The answers are available in the book, Hidden Facts in SSCE Mathematics, either in the hard copy or the soft copy given at the bottom of the screen. Thank you.